All right, we are back, and this is Thursday, April 23rd. This is going to be our last lesson for the week. Tomorrow, you guys are going to get a review to do, and then you're going to have a quiz on Monday. So make sure that you're staying up with the work. So we are going to solve more exponential and logarithmic equations. So here's a problem. Okay, if I have two natural logs on one side and nothing on the other side, I can't just make like x plus 3 equal to 4 because there's not a natural log with 4. I'm going to have to do something that we learned about condensing our left side. So since there's an addition sign here, that means that we are going to multiply, right? We're going to multiply. So this one's going to be the natural log of x times x plus 3 equals 4. Okay, so we're going to condense right here, condense. So now I'm going to multiply that out. The natural log of x squared plus 3x equals 4. Now I only have one logarithm. So what did we learn yesterday? If I only have one logarithm, we are going to have to make this into an exponential form. So what is the base on natural log? The base on natural log is e, and then I'm going to have to go like this. So e to the 4th equals x squared plus 3x. And this is about the ugliest equation that you are going to get. You're going to have to open up Desmos, more than likely, or a graphing calculator. And on one side, we're going to have y1 equal to e to the 4th. And then we're going to put this one on y2 equals x squared plus 3x. And then we're going to have to find where the two intersect. It could intersect in one position. It could intersect in two positions. This one does intersect in two. So I get x is approximately negative 9.08 and x is approximately 6.04. Don't forget, we always need to check. So when I look back up at my first equation, I'm going to put my values in there. Can I have the natural log of a negative number? The answer is no. So if I put this in for a negative, for my x value, can I take the natural log of negative 9.08? No, this is an extraneous solution. Now we're going to do it with our 6.04. Can I take the natural log of a positive 6.04? The answer is yes. Then I go to the second one. Can I take the natural log of 6.04 plus 3? Yes, I still get a positive number. So this is going to be our answer. So you are going to have to graph if you get anything like this. Okay, let's go on to our next one. Here we go. We have two logs on one side and none on the other. That means we're going to have to condense. I see that there is an addition sign. That means to multiply. So I'm going to have the log base 3 of x minus 9 times x minus 3, which equals 2. So let's go ahead and FOIL that out. Does everybody know how to FOIL or distribute? When you do that, you get x squared minus 12x plus 27. Any questions there? All right, so to FOIL, don't forget, you multiply here, x squared, here, negative 3x, but we also have a negative 9x, which gives us the negative 12x, and negative 9 times negative 3 is 27. All right, now we have only one log. One log means we transform it into exponential. So I have my base of 3, 3 squared equals. So 3 squared equals x squared minus 12x plus 27. 3 squared is 9 equals x squared minus 12x plus 27. I can subtract 9 from both sides. 0 equals x squared minus 12x plus 18. And then from there, we can try to factor. Bad thing is, this is not going to factor. I could have a negative 2 and a negative 9, which gives me a negative 11. So this is not going to factor. Guess what we're going to have to use? Oh yeah, and I am going to sing it for you because you miss me, right? So we're going to have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Don't even say you didn't smile when you heard that. Okay, so we have x equals, opposite my b is going to be 12, plus or minus the square root of b squared is 144 minus 4 times 1 times 18 all over 2 times 1. All right, now we got 12 plus or minus. Put everything underneath the radical into your calculator, and you get the square root of 72 all over 2. Yep, I'm going to do this one too. 72 is not perfect. So what are we going to have to do? Somebody said it out loud. I heard them. You're going to break it down. So, I know you miss me. We're going to take that 72 and break it down. And we're going to break it down into 9 and 8, 3 and 3, 2 and 4, 2 and 2. Ooh. 2 and 2. So I have a pair here and I have a pair here. So we have x equals 12 plus or minus 6 square roots of 2 all over 2. Now that will reduce to be 6 plus or minus 3 square roots of 2. Now if we put 6 minus 3 squared to 2 into the calculator, and then we subtract 9, the negative's not going to work. So our only answer is going to be 6 plus 3 square roots of 2. And that is our answer. Always check it back into our values here because we cannot take the log of a negative number. All right. So next, yep, those were a little bit difficult. I wanted you to see them. Okay, so for our next one, we're going to be solving exponentials. On this first one, I look at my base and I look at my other base. Can I somehow make them the same? And the answer is yeah. I can't do anything with the 2, but can I make this 2 to some power equal to 8? 2 to the first is 2, 2 to the second is 4, 2 to the third, and then I have x plus 3 on the outside. Well, what has to happen right here? We have to multiply. So I'm going to have 2 to the 4x equal to 2 to the, and I'm going to have to distribute 3x plus 9. Since my bases are the same, I'm going to set my exponents equal to each other. So 4x equals 3x plus 9. Subtract 3x, subtract 3x. X turns out to be 9. And that's our answer. This next one is a little bit more difficult. Not real bad though. Our bases for 25 and 5. Can I make 25 with a base 5? The answer is yes. So 5 to what power is 25? That's going to be to the second. And then we had to the x plus 3. Equals. Somehow I'm going to have to get that 5 to be in the numerator, not the denominator. I need it up here in the numerator. Well, all I have to do is make it to the -1. Isn't 5 to the -1 1/5? And then I'm going to take that to the x minus 7. Now, distributing, I have 5 to the 2x plus 6 equaling 5 to the -x plus 7 because I had to distribute. The bases are the same. 2x plus 6 equals -x plus 7. Add x to each side. 3x plus 6 equals 7. Subtract 6. 3x equals 1. Divide by 3. And x equals 1/3. So your key is to get the same bases. Make your numbers the same bases. All right. Oh no, what do we do here? Can I make 6 and 60 have the same base? No, because 6 to the first is 6, 6 to the second is 36, 6 to the third is not 60. So we are going to change to a log. So log base 6 of 60 equals x. And you know by now you can probably put that in your calculator by doing alpha window 5, or you can do the change of base. To do the change of base, remember we have a log over a log. What's my base? My base is 6. 6 goes in the basement. 60 goes on top. So if you put this in your calculator, that's going to equal x. So if you put this in your calculator, you're going to get x is approximately 2.285. And that is our answer. Same thing over here. I can't make 603 with a base e. So I'm going to have to change to a log. So this is going to be log base e of 403 equals 3x. Well, what does log base e mean? Log base e means natural log of 403 equals 3x. Can I get the x by itself? Yeah. I can divide each side by 3. So now if I put that on my calculator, x turns out to be approximately 2.0. And that is our answer. All right, we have one more set of problems here. The first thing we do is we try to get the base on one side by itself. So to get my base of 5 on one side by itself, I'm going to have to add 3 to each side. So 5 to the x plus 1 equals 125. Ooh, can I make 5 and 125 have the same base? And the answer is yes. 5 to the x plus 1 equals 5 to what power is 125? 5 to the third is 125. Since the bases are the same, x plus 1 equals 3. Subtract 1 from each side. So x turns out to be 2. And that is our answer. Okay, last problem for the day. My base is 3. Is my base on one side by itself? No, it's not. So I need to get rid of that 4 times. To get rid of 4 times, I divide by 4. So 3 to the x equals 6. Can I make 3 and 6 have the same bases? The answer is no. So that means we're going to have to change it to a log problem. Log base 3 of 6 equals x. Here again, you can either put it in your calculator, alpha window 5, or you can do the change of base. Change of base is going to be log 6 divided by log 3. 3 is my base. It goes in the basement. So x is going to be approximately 1.631. Any questions? All right, so what ways can you solve logarithmic equations? You can change them to exponential. If they have logs on each side, you get rid of those logs, set it equal. You might have to condense one side. There's so many ways. Please look at this video. Make sure you're writing down notes. And your assignment for today is Big Ideas 6.6b. Make sure you're doing these because tomorrow you are going to be reviewing. Any questions you need to take to your teacher because your quiz is going to be on Monday. Have a good day, and I'll see you tomorrow for our